Hi. Okay, great. Hello. So today I'll share some real world data challenges you might encounter as you do more data analysis with the skills that you learn from PLANIT-ed. And you can think of this session more of like a story time than a lecture. So I hope you can kick back and enjoy it. And after the lecture, we'll have a workshop on working with basic data structures in Python led by Sang-Yan. Well, I started my career as an environmental campaigner like y'all, but I got retrained as a data analyst about 5 years ago. And I joined Ember as a data analyst 3 years ago. And as you know, Ember collects data from all over the world to track global electricity transition at various levels. So every day I have to work with a lot of data from different sources. And when I first started learning how to code, I was really naive. I thought I could just do analysis with numbers, I thought I could just like start analyzing. But no, that really wasn't true. I had to spend a lot of time cleaning data before I could start even doing any analysis. So for the last 5 years of working as a data analyst, I feel like I've been a cleaner more than an analyst. And you wonder, why is that? Well, let's think about it. Between these two rooms, which one would you prefer to live in? Probably the clean one, right? Right? I hope so. And also does data analysis and modeling. If you have unclean, untidy data, then you'll get wrong, inaccurate insights. You'll have a lot of errors and clutter in your model or in your results. And actually, oftentimes, you can't even do any analysis with it. But when you have clean and tidy data, the results of your modeling will be much better, with much useful insights and greatly reduced chances of error. Then what does clean and tidy data look like then? Let's take a look. Clean data is complete, valid, accurate, consistent, and readable. And let's go through each of these characters one by one. A data set is complete when each row or column forms a single data point, therefore an observation, meaning there are no merged cells or multiple entries in each cell. And it must have no duplicates or missing values. And data is valid when variables have the right data type and fall within the range that it's supposed to be in and have the category that it's supposed to have. Data formatting is also very important as well. So like when you fill out a form to like sign up for something or like submit your survey, if you put your name in the like phone number field, for example, then the computer often tells you, oh, it's the wrong data type or it's the wrong input. And that's because the program behind that is testing for the validity of the input data that you have provided. So like constant checking of validity of data is important. And data must also be accurate. So no false values, no outliers, and there are many techniques to test for these false values and outliers. And oftentimes you also have to like rely on your instinct, in your intuition to see what is false and what is an outlier. And consistency means data keeps using the same unit of measurement so that each number that you see in the data set are comparable to each other and following the same format using the same naming conventions. And in terms of readability, all the names and variables in the data set, they need to be easily understood by people and also machines too. Machines don't really like special characters or empty spaces. So, like the characters you get when you press a number key while pressing the shift key down, So those are not very welcome by machines. And also variables shouldn't have duplicate names, because otherwise they can't tell the difference between two columns. And these two attributes will make your data readable by machines, meaning you can do analysis programmatically using Python, or automate your analysis and so on. And this allows you to handle much bigger data sets in a more systematic way. And clean data reduces errors. So it reduces errors, and furthermore, since it's much more readable, it's also reproducible. Being reproducible means that your analysis can be replicated, can be repeated by another analyst or even your future self. And this is quite important as well, because your piece of work can then be checked by others and yourself. I'm sure you've had an experience where you have this giant Excel sheet where you have calculated a lot of different variables, and then you can't really quite retrace back how you arrived at that result. But if you are sort of writing each of those steps of analysis down in a Python script, for example, then it becomes much more readable, and much more, the methodology itself becomes much more transparent to yourself and to the outer world. And having clean data was all about hygiene, right? While having tidy data, it's about better organization of data. So each variable should form a column with observations in rows, similar to what we saw in clean data. And the columns and rows, they need to be ordered in a meaningful way. Again, having a tidy data set will ensure that your data is machine readable. Have you ever color coded some cells in your Excel sheet to highlight something? To, like, for example, maybe you wanted to indicate their category. But if you read it in your Python script as a data frame, then it won't be readable. It won't like understand that it's a data point, because you haven't put that information in neither row nor column. So in order to have it read by machine, you have to have all the data points in each of the rows and columns. And having a tidy data set can also help you standardize your data set. And standardization is quite important, because it helps your data be used by other analysts and other projects. And this is also sometimes referred to as data interoperability in a very narrow sense of the term. And this is quite important to reduce work that goes into cleaning data, and also to ensure that data is shared with less barrier. And again, having a well-structured data set minimizes errors, and you'll often find that in the process of cleaning and organizing data, you will spot errors because the process will kind of like the process won't work if the data isn't clean or tidy. So the process of cleaning itself helps you find the errors and do something about them. I'll show you an example of clean and tidy data. And by the way, if you have questions, feel free to just raise your hand and ask. So I brought Ember's monthly electricity generation data. And each row here forms a single observation. And this data set has 6 columns. And each column represents a variable. And here we have generation in terawatt hours and share of generation in percentage as 2 variables that are present in this data set. And here, as you can see, there are no columns that are merged or duplicated. And in this case, let's see row 3, then that's a single observation about Argentina And on 2018, January 1st, their coal generation was 0.26 terawatt hours, and the share of generation out of total electricity generation was 2.04. And I'm sure this is common sense for you, but like when you are cleaning data, it's important to kind of like register the fact that this is how a tidy data should look like. Another type of tidy data is when you have all the variables present in the data set in a column, so that each row represents a single data point. So, for example, here, let's see. Sorry, I think, yeah, that's the slide that I wanted to show you. So here, as you can see, all the variable that we used to have on this column right here, they have now gone to each rows. And now we have a new column called variable. And this data format allows you to have literally one single data point for each row. And this type of tidy data structure is called long data, because you are sort of presenting your data points like in a long format. I don't know how else to describe it. But there's another type of data structure that is wide, because if there's long, there's also wide. And in a wide data set, you can only show one variable, meaning after, so like the first 4 columns, they show you the type of continent that the country belongs in, the country name, the country code, and generation date. And the actual data point that we are interested, sorry, I was reading the comment. Yeah, where was I? Oh, yeah, so like all the, yeah, so this one is only showing, I think this is showing absolute generation in terawatt hours. And here you are seeing only one type of data point, which are distributed across columns. And now the category of fuels are presented in each of the columns. So in this wide data set, you cannot show other variables like share of generation. In order to do that, then you have to sort of like copy everything, copy all the fuel categories and make a separate columns to represent another data point. And this type of data structure is often used in a lot of programs that visualizes data. So it is quite important to understand the difference between wide and long data sets. And of course, in using the library pandas, I will learn how to do that as the session goes on. Great. Yes, so having, so when you have clean and tidy data, then you can be happy and move on with your analysis. Great, but working with data in the real world is actually quite messy, like really messy, to the point where analysts say 80% of data analysis is spent on cleaning data because it's messy. But don't worry, the Python skills that you're learning in this course is your friend, and it's a tool that will give you clean and tidy data. But that's Sangyun's job for today and the rest of the course. But my job today is to share with you experience that I had with messy data, so you're prepared for the real world stuff. I also work for Planet, by the way. I split my time halfway between Planet and Ember. And a lot of the examples that I brought today is from Ember. Ember, we maintain a database of 2030 renewable targets in gigawatts. And to collect data for this, we went through 96 countries' energy policy planning documents manually, one by one, and recorded them literally on a spreadsheet. And this shows sometimes the data you're looking for isn't provided in a spreadsheet. Someone somewhere in the world has to do the hard work of collecting them and putting them together with standardized formats and replicable processing. And in this case, as I mentioned, this capacity target had to be collected in gigawatts, not anything else. And to make it worse, many countries report their target not even as numbers, but as images. Mexico doesn't have a declared target in gigawatts, but this is hidden in this like awfully presented image. And we had to use a tool called Webplot Digitizer to sort of kind of guess what that number is actually, to extract data from it. And in Malaysia, they give this very nice table, but it's not text, it's an image. So machines can't read it. And since we're dealing with 98 countries, of course, we run into language problems too. We rely on Google Translate to understand it. But since we're not fluent in the language, the likelihood of getting it wrong is really high. So we have to often reach out to local partners in the region, in Japan or in Thailand, to actually like ask them, are we interpreting this data correctly? Another example I wanted to show you is Ember's monthly electricity data. We collect monthly electricity data from 59 national statistics offices. A lot of the times they provide data in very nicely presented spreadsheets, so we're quite happy. But we still have to go through the process of extracting, transforming, and loading them to our internal database. And transforming means, and extract, transform, load is like a very usual data processing steps that a lot of data engineers will follow. And this process basically standardizes all the data sources from 59 national statistics offices. And that's process of standardization would also, in other words, process of transformation is all about making all those data sets clean and tidy in the same format, so that it forms a global database that is comparable to each other. And of course, there are a lot of challenges related to it. It sounds very easy, but it's a very sophisticated pipeline of data sets that we have to maintain, which involves close to like, I don't know, I think last time I checked, it was like 10, yeah, I think it was close to like 50,000 lines of code. And we also have to, once we are finished with collecting, once we're finished with the extract, transform, and load process, we also have to validate it and have them ready to publish to the outer world. We don't really want to publish any data that we're confident about. So we have to go through a very rigorous validation phase. And we still get reported that we have error in our data, because there are just genuinely a lot of them. Yeah, and during the collection phase, we also run into similar data challenges as I mentioned before. For example, Pakistan's monthly generation data, it can't be read by machines because it's reported in a scanned image of a report, which is hand signed, because it has to be approved by the higher person up in the chain. So we need to manually extract it. And we often joke about how like this should be plain illegal, but it still gets done. And Vietnam's generation data, it's basically a post on their website. So we have to get that manually too. And another challenge we face is that data formats vary across sources a lot. So the data on the left here is for Malaysia, and the right one is for Japan. And to create a global data set, we have to merge them together. And to merge these data sets together, we have to make sure that the data is clean and tidy using the same standard. I'm going to sound like a broken record because I'm going to keep saying clean and tidy. And to do that, we have to make sure, to do that, we have to change the way that the date is expressed, and to make sure that the data points are in the same unit. And the variable names also need to be the same. So here we will have to Google Translate the column names and change that. And also we have to change the units here. And more often than not, sources will report different units. Sources will report data using different units and at different granularity. Granularity means whether it's monthly, yearly, or hourly. So the more granular you get, the more information you have. So on top of changing the data structure, we have to ensure that the data at hand have the same granularity using the same unit. So for example, here, this Japan, so here, Japan's hourly generation data, it gets reported in megawatt, while Korea only reports at monthly level in gigawatt hours. So for this case, we would have to group all the Japan's hourly generation by month and add them all up. And then change that unit to gigawatt hours to make them comparable to the Korean one. Other key challenge is missing data. So at Ember, we break down electricity generation into solar, wind, nuclear, hydro, and other renewables, also coal, gas, and other fossil. And oftentimes, we don't have the same fuel breakdown. For example, Malaysia, even though it's the same country, the data for Sarawak and Sabah, they don't report at hourly generation, but the Peninsula Malaysia does. So we have to sort of interpolate the missing data from Sabah and Sarawak to have a complete picture for Malaysia. China is another example. China reports coal, gas, and oil generation all as the same thing. So there's not enough granularity for their fuels for us to understand, for us to have the full fuel breakdown. So what we do at Ember is we use the IEA's historical monthly generation data to kind of guess what the breakdown is. And the availability of data also varies by country. For example, Oman's generation data starts all the way back from 2015, but it doesn't report recent months because it's very lagged. But Bangladesh's generation data set only starts from 2018, but they have much more recent months data. And for our global data set, if we don't have data for recent missing months, then we use a model called ARIMA to estimate the missing months generation. But it's not super accurate, so we use it only for our internal analysis. We try not to publish data that we're not really confident about. So to address all of these challenges, you'll learn how to use pandas in this course. Pandas is a Python library for data manipulation and analysis. It's very widely used and has a very long history. It can handle all kinds of source data file types like CSV, JSON, Excel, and many more. Parquet, DB, I don't know. There are many data types. There's a new library called Polars that came out as an alternative to pandas that's meant to do the same thing, but much faster because it parallel processes a lot of stuff. And I really like it, but I keep going back to pandas because so many projects already depend on pandas. For example, we're doing power systems modeling for Jeju Island in South Korea at the moment, and all of the pipes is built on pandas. So I have to keep using pandas, even though I prefer polars. So polar panda, as you can, and that kind of shows how universally sort of like used pandas is. So the dependency is quite strong. And in pandas, there are various data structures. One type is series. It's literally a series of data presented as a line with an index attached to it. We consider this a one-dimensional data structure because it's literally one line of data. And the other is a data frame. This is more like the spreadsheets you use. If you load a spreadsheet to your Python script, then it'll give you a data frame if you read it in as a data frame. And yeah, so in a data frame, there are columns and rows, as we talked about in tidy and clean data, and that forms two-dimensional data structure because there are two lines now heading in different directions. Data frames can also be seen as a dictionary whose keys are columns and values on series. I think we learned what dictionary means in the last session with Sang-hyun. So that's an alternative way to create, pandas is next week apparently, to create the data structure. Yes, and with pandas, you can read and write data, explore data, handle missing data, filter, select, transform, group and aggregate data, merge, join, pivot data sets so that you can have a clean and tidy data set so that to do your analysis with. And hopefully by the end of the 8-week course, you'll have mastered how to use pandas. And that's the end of the session. I hope it was a good story. And and I've reserved some time to get questions from you. And also, I would love to hear your experience with working with real world data. This would also be a great place for you to kind of like ask some questions that you thought that you've always had about data processing or doing analysis. So feel free to put your questions on the chat or just ask away.